Electro Noob Geeking Out.
So I've written a tool to create 1-bit audio for microcontroller projects. This is what it sounds like.
Right, so sorry about the audio. Microphone's picking up a lot of hiss, and the the noise suppression algorithm that comes with the system or whatever. When I turn that on, it's a little bit too harsh. Gives kind of iffy reproduction in the recording, so forget it. Right, so this is the sample I used in my demonstration, and also which is the sample data which I added to my GitHub repository where the files are, and I'll explain that further later.
My name is Ozymandias, King of Kings. Look on my works, ye mighty, and despair.
Absolutely love that. I think this guy sounds incredible, so that's just, yeah, that's amazing. This file is Creative Commons, so here's the attribution to it. It's absolutely brilliant, and Speedenza, I believe, URL is up there. I imagine it's pretty easy to find. I've also linked to it in my source code as well. So, what else? As you can see, the file is 10 seconds long, 1.3 megabytes. My exported version, after I had downsampled it, but I'd also cut off, as you heard in the beginning, I cut off the first half of this sample, so I'm just starting.
Look on my works, ye mighty, and despair.
That's the only bit I'm keeping for my demonstration, but let's just pretend for a moment that we cut this file in half. So, you know, a half of even 1 megabyte, 500k. The exported file is about 2k, I think. I mean, it's in source code format, so it's bigger than that, but it's got the array of data, which you'll see shortly. Yeah, I think it's about 2 kilobytes of memory or something. So when you program a microcontroller with it, you've got loads more room. And in fact, that wasn't just downsampling it from the 24-bit depth, which is here, if that makes any sense. In other words, the bit depth is how many variations there are per sample. So, for example, so if we look at, say, about, if I click it, it's going to play. Sorry.
Look on my works.
Yeah.
Look on my works, ye mighty.
Okay, you see where the bar is stopped there. If we were to check the value, that precise moment in time, and that location in the audio file, we will find that on the scale from sort of like 0 up to whatever 24 bits give you, I don't know off the top of my head. Let's pretend it's just been downsampled to 8-bit. That's easy for me to explain, hopefully. So that particular sample, and you see where the waveform is really, really thin because there's not much amplitude. So if it was an 8-bit sample, you would have 256 shades of grey. Essentially, you'd have, you know, you would have, you know, if there was no sound detected whatsoever, then there's no energy, it'd be 0. And then, you know, at the very maximum approach, you know, and to where it would start clipping the audio off, you would reach 255, which is useful, but not quite what we want. So what I do instead is I convert that by choosing, do I want to class anything above the number 0 as switched on. This is a lot harder than I thought to explain. Wish me luck. Okay, so I've spilled a drink all over myself and all over my face. Oh, it's lucky I've got lots of hair. I'll save that for later. Right. I've chilled out a bit now. So, instead of having all of those variations, basically what I've said is, if the volume is about sort of maybe halfway, then we'll class that as switched on. And anything below that is switched off, which is pretty simple. I hope that's as clear as it needs to be. So I'll take the sample, 0 through to 255, 0 through to 255, because there's 256 variations, and I say if we reach like 100, yeah, we want the pin to be switched on, and if not, not. Okay, in an attempt hopefully to demonstrate that, let me switch over to VirtualBox. So this is the original file that we got here, cut in half, as I've probably explained. This will be played back now as 1-bit audio at 44.1 kilohertz. Not too bad. Okay, so what I can do now is, because we've already crushed the bit depth, what we do have though is we've got the bit rate. So what I've done here is I'm using division. Okay, so in my header file, which contains the Ozymandias sample, I've specified the bit rate, so I know how many samples are in that array. So what I'm doing here is I'm just dividing it by a certain amount. So if I do, obviously we all know, divide by 0. Little joke there. Okay. If I do 1, where it doesn't change the file at all, the output, it just sounds 1 bit. Sounds pretty good. Okay, so if we want to obviously divide the bitrate by 2, so we get 22050. Not a lot different. Let's go divided by 4. I still consider that to be pretty good. Let's divide it by 10. So that's about what, 4K roughly. I love that bit crushing sound, it's so good. Okay, you get the idea, right? So the duration of the song, you know, the playback doesn't really change. It's just how many samples we have per second. Right, so just to clarify one thing, the input parameter in my code doesn't work yet. It could be any file name, it just doesn't check. Doesn't read the file rather, because the sound data is stored in this file at the moment. It'll be changed, to be fixed, I just haven't got around to it yet. Like between making the crusher, getting it to work on the Arduino and creating this video, this video presentation from YouTube. It takes a lot of time. It's surprising. It really is. Yeah. So there's the sample. Now the way I created that file for the demonstration is like the following. Okay. So my workflow was roughly this. I was logged into freesound.org. I checked the license agreement. Then I downloaded this sample that we know about. Okay. Then I opened that file in Audacity. Like so.
My name is Ozzy Matt.
As you can see. Now, some files you'll want to open, they're stereo, so you will want to split the audio channels up, which you can do here in Audacity. So you can literally just split into mono and then delete one of the channels. I didn't really need to here, I don't think, because, well, it's mono. Oh, excuse me. Oh, you'll notice though, here it says it's 32-bit float. What that's basically saying is you've got it's floating point as well. So not only do you have your steps in whole numbers, but you have very, really detailed resolution breaking down each step, so that you can get really good. Can't think of the term right now. Yeah, forgive me, but it reduces things like the noise floor. And when you are using the effect internally into the software, if you're working with something with loads of dynamic range, is what I was looking for. Loads of dynamic range. You can do whole loads of things to it without really ruining the overall sound quality. But if you've got something that's really downsampled, not very good, and then you run it through processors and things, you don't have as much information to work with, therefore the quality is less. And so when you're working with these audio workstations, or in this case the audio editor, they like that extra headroom to basically process the audio and have lots of room so things don't distort very easily and stuff, which is great, actually, really, really great. But unfortunately for what we want, yeah, not so good. Now, because I was really eager to try this out, what I did was I used Audacity, like I'm saying, then I did export, so which is a file name, whatever. Okay, we make sure that we're set to uncompressed, so other uncompressed files, options. Now I don't want a header on the file, so I set it to raw, headerless. By doing this, it makes processing it in my program so much easier, because I'll know the bitrate, I will know the sample depth, I will know, yeah, I feel like there's a third thing, but probably not. But I'll know the key things, you see, that's it, and that's it. And I'll know it's mono as well. So I know where the samples will be laid out in the file and everything, because it's very simple. It's just in one long stream. Whereas, if it's stereo, then it's every other byte is left, right, left, right, left, right. You've got your WAV file containers, which you can support multiple channels of audio. So you could have, like, if you've got 5 speakers, say, then it'd be bytes 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You see, so it's sequential in that manner as well. It's quite nice, but as I say, for now, for my code, to get this working, raw, headerless, and the encoding, that's quite important. Make sure it's unsigned 8-bit. That essentially means you can have a value between 0 and 255. If you're not sure why that's important, just look up the differences between signed and unsigned integers and stuff in C. Alright, so we do that, we hit save. Now, assuming I saved that, I then use this program called HXD. Now, I've loaded in a example To show you the about box quickly. Okay, that's the one I'm using. It's actually awesome. It's really handy. The reason why this is a cool step is because if you've got to export C, then what it will do is it will basically take that raw data that we've exported from Audacity and generate a C file for us. As you can see, I've created that. So there isn't much you need to do. You can choose C or C++. I don't know if it really matters, but I exported to C because the program I'm using under Linux is, well, I'm writing it in C, so yeah, no brainer. Now I'll open this file up in Notepad++, and what you'll see is the size of the array is already populated for us, and you'll see here it's an unsigned char, raw data, da 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 da. Yeah, makes sense. And this here is all the hex values to create, or sorry, represent our audio file. That goes on for quite some time and then closes off here. Okay. All I did then is to take that information, including that declaration of you know, unsigned char, raw data, da 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 da. Ta-da! Looks like that, doesn't it? So as you can see, I should probably do it side by side or something. Unsigned char, raw data, da 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 da, same size, etc. That's it. I don't think there's anything else in the file. I think it just ends the same, to be honest. Yeah, exactly the same. Right then, so we've got the sample. My program knows about it because I'm always hitting caps lock, because in my program here we're pulling in sample.h. Yeah. What my code should do, as I've already said, is here the input, although it, you know, it pulls in that parameter, takes the file name argument and everything as you'd expect, well, that's fine, but it doesn't. I don't have any code here for opening or closing files, so yeah, I'll add that soon. Okay, now then, so we're at the stage now where we're pretty much ready to do something. So what you see here is crusher, ALSA, input, bitrate. So the ALSA tag is just to say that we want it to come out the speakers, just so we can preview it. Now let's pretend for a moment that that's perfect and we're ready for it. Then we'll just send it out to standard output, which is essentially the console, the screen you're looking at now. Yeah. So what did we do? So we reduced the sample rate by 10. So we divided the sample rate by 10, which gives us now basically 2,000 odd bytes of memory used. Yeah. But because of the way we're doing this, and it's in 1-bit audio, we technically got 18,000 samples. Yeah. But anyway, so we've got 2,000 bytes or whatever. That's not much storage. That's minimal. That's, you know, you could store a whole load of these in your, you know, tiny little arduino or whatever with 30 odd K of memory. Alright. Now then, as you can see here, my program defines these just so when you're writing code with it, it's just a lot easier. The interesting thing though is if I let's get rid of the ALSA bit because it's a bit annoying, it keeps playing it. If we look at the beginning of the output here, what we'll see is it's been designed for microcontrollers, AVR specifically, here's the array, but also you notice that I'm setting it to progmem. Now under the Arduino stuffs, here you go. As you can see, you need this header file. Yeah. This tells you as you can see. So I'm using proguchar or unsigned char. Yeah, it's only 1 byte of memory, 0255. Exactly what I've been saying all the way along. It's consistent. So you'll notice every step of the way we're sticking to the same format. Yeah. These examples are fine, I'm sure, but you don't have to worry too much because, as I've already said anyway, there's the Arduino project file. So, at least I think I've said, I've cut out loads of material. It's taking me ages to produce this video. I've made so many mistakes, so I can't remember what I've said and what I haven't said. But essentially, you know, this is the output. Now, so what I could do is, so if I was to go into the Arduino part, like so, okay, I could really, I mean, as you can see here, I've got the include file. I craft this by hand, not all the X values, but you know, I created the file how I liked it and got it working, and then I've included that as an example. Okay, so just quickly showing you the Ozymandias.c that I generated earlier. Here's the original file size, and as you can see, it's 188 kilobytes. You know, way too much for the Arduino IDE. And in fact, having said that, if we go to here, see just here, the Arduino IDE will actually import that as part of this project. So, which is kind of odd. Well, it kind of makes sense, but it's kind of odd because the .ino file is essentially, you know, the main.c, if you know what I mean. That actually contains source code rather than it being some kind of like project file container type format. No idea why they did that. Right, so as I said, we'll go to the Arduino IDE. And you see it opens up like that, but it's also imported this C file that I just saved a moment ago into the same directory, which is handy because I just demonstrated something quickly. So just make that full screen. We'll see here it says 188 kilobytes. Also, I'm using an Arduino Nano, essentially an 80 mega 328. Sorry about that. I haven't got it connected right now actually, but that's not important. So hit verify, and you can see here, see, it's just too much data. You can't compile that in, unfortunately. But that's fine, because if we just close this quickly, get rid of that C file, the actual one that we generated after it's been through the crusher, it doesn't say what it is there, the size, but it doesn't matter because the compiler can figure the size out anyway. But we have it here for convenience. So what you'll see here is, so we've got 2,000, nearly 3,000 bytes. Let's hit compile. Might need to, I can't remember. Okay, so our sketch is 3.8K. As you know, plenty of space, and you know, could have been 30K. Right, so there's that, that's done. Everything else, what's there to say about this? If I remember correctly, yeah. If this array is too big, like you've got too much data in here, like I said, it wouldn't compile. But if you set it to this kind of thing with progmem or whatever, I think sometimes you get like a different error. Something it's a bit confusing. I can't remember if I had to update the Arduino IDE to find out what the error actually was. But what was really infuriating is if you copy and paste this kind of data, you know, like loads of big chunk of text like this into a new project, and then try and save. I don't know why, but kept crashing, crash, and it wouldn't save any data. It looks like it's saving the file. It creates the file, opens the file for writing, you know, but unfortunately, it's empty. So it's a little bit irritating, because obviously if you're writing code and you paste this in and and you haven't saved in a while because, well, you haven't, and then you lose what you've done. Yeah, that happened to me a couple of, like 2 or 3 times. Not cool. Anyway, there we are. You can see that it compiles. Speaker pin is 5, pin 5, digital pin 5. That's it really. I think in the example I uploaded, I think I might have got rid of these comments here as well. Not that it really makes any difference. I remember. The reason is because this particular one here, you'll notice the delay microseconds is 227, and if you look at the code here, I think we'll find out. Yes, and you'll see here where I've set the delay to 23 microseconds in comparison to the 227. Well, you know, it's probably quite easy to guess pretty much immediately. I'm using a division factor of about 10, I think. It might be 8, but it could be 10. I don't remember exactly what it is, but let's just pretend for a moment I'm doing a division of 10. So instead of doing 44.1k sample rate, I'll be doing 4k. I want to take a moment to talk about the GitHub page. There isn't much on my GitHub, admittedly. It's the first time I've felt that what I'm working on is really worthwhile to anyone else, or some other stuff that I do that is closed source, unfortunately. But anyway, so I can't remember because of how much video I've edited for this particular tutorial. Yeah, so I called the toy Beverly Crusher because obviously it's crushing audio samples, and I like Star Trek a lot, so here's my GitHub. Awesome picture that this lady created. If I just click here, here's a deviant art. She makes some really cool stuff. Yeah, so she has a note here that she would like it, at least if somebody's going to post her content online, at least, you know, link back to her. And I think that's obviously very, very reasonable. Now I say that, I posted on her profile asking permission to sort of associate my software with her image. I haven't checked the reply yet, so I just got a sinking feeling because I'm worried that I can't use it, and then I'll have to edit my video and edit it out and whatever. Let's click it. Let's see. Oh wow. Okay, how awesome is that? I am so happy. Like really happy. Oh, that is awesome. Oh yeah, she's cool. Oh, that's made me so happy. I'm glad also that I'm recording this as I've opened it, because that is brilliant. Yeah, I like that. Some people are really cool, you know. That is special. Okay, so yeah, so this is the digital art she did. I think it's amazing. I just love it so much. Like really, And it's not like I've ever been like a major fan of Beverly Crushers, but it just kind of goes well, doesn't it? Beverly Crusher, what a cool name for a program for crushing audio. Right, so Beverly Crusher is my website link. There's not much on my website, it's not much to look at, unfortunately. This gives a little bit of information about the command line options. As I say, it's not quite finished, but it's nearly finished. I'm hoping that if anyone has the time to add to my project, that'd be really cool. I'd appreciate that a lot. That would be really nice, especially for the exporting of the data. It'd be really nice if different microcontrollers could be added and their variations and what have you. That'd be really nice. Examples for loads of different ones. I think that'd be, I'd be really really grateful and really proud to add those to my project, or anything else you would like to add, so please do. And also check out this chick's art, which is brilliant. Okay, what else is there to show? Yeah, again, I can't remember if I have or haven't, but I'm using an add-on called Build Number, and Build Number is really useful. I forked the project, and I was going to edit it. A couple of bits I want to change, but I don't know if I'll get around to it. But is it this far? Yeah. I'm trying to think of a useful. Yeah. Okay. Yeah. So in your code, you've just got a couple of things to do. So you just include the build number.h, and inside of there, again, I don't remember if I explained this or not, so please forgive me if I'm repeating myself. Yeah, that's it really. His program just updates this integer. There's not much to it, but at the same time, when you start looking through the gentleman's code, you start to see that it's gone through the trouble of supporting Visual Studio, as well as making sure that it outputs properly for C and C++, as well as, which I think is really cool, is and also an example makefile, which you will definitely need to change. But yeah, that's it really. You just call his binary build number and it updates it, and then you compile. Simple, but it's so nice. I really like it. I like it so much that I'm gonna say it again. I really like it. Yes, so I can keep a track of my builds now. Hopefully that means if there's any bugs or issues, and hopefully that's one way to know where we're at. Right, well, enough waffling. Thank you very much for taking the time to watch this through. If you have reached the end, I'm impressed. Thank you very much. I appreciate it. What else? Oh, and a demo, I guess. I'm going to put in a demo at the beginning of the video, and then I guess I'm going to just put the same demo on the end or something. Something. Right, so here's the visual component to the demo, I guess. So I've just got quite a nice little speaker actually. Yeah, that's connected into this mess here. I've just got a little one of these little Arduino Nano boards that you can get from China for practically no money. The audio running into there. Onto pin 5, as I've already described a few times in the source code, etc. The LCD isn't being used for this particular project. It's wired in. I was going to go through the hassle of making a little intro, but I haven't, so sorry. Use your imagination. Right, so we've got the sound file there. got the sound making device there. I can't remember why I put it on there. I think it's because it just sounds a little bit bassy. Please excuse the world's most crude power supply. It's pretty nasty looking, I understand, but I needed something, so yeah. It's kind of cool actually. Let me deviate slightly. So I knock everything over. So what I can do is got a big board here with a Molex connector, and I'm classy. I'm using a resistor as a way to tie off the wire. Anyway, so that just plugs into the power supply here, boom, and then sends power to there. Isn't that wonderful? Sorry about the background noise, someone's using the sink downstairs. Okay, so we just give the thing 5 volts, like so. Okay, so I've had enough of that now. I must have heard that sample 1,000 times. Okay, so there's the demo, there's what it is. I'm really happy. I like it a lot. There's a lot more things I need to do in the future that are running around in my mind I need to do. You know what that's like, I'm sure. Okie doke, well, peace out, bye.